So perhaps one of the most well-known thin film interference effects are the pretty colors that you see in bubbles. So here we have a bubble machine. This is sort of the Lawrence-Welk version of 201X boards. And you can see as they go by, in these, a little bit of red and a little bit of green show up in the bubble color. Now, you've probably noticed this, and I encourage you to go do it again and enjoy the colors. One thing you may not have noticed is watch a bubble until it dies. If you really watch one till it goes, something very interesting happens. Let me see if I can find one that, here we go. This one's hanging out, and it starts to lose its color, and it starts to get black spots on it. And if you really watch it until it completely pops, it goes almost completely invisible before it pops. Here's another one. You can't really even see it. It goes just completely zero reflection. Right? So to really show you this, you'll need to look at it on your own on a bubble. But to really show you, I need to capture one, and we'll hold it and we'll really zoom in on it. So to capture one, I need to blow it first because the moist bubbles capture better. Right? And then I'm going to try to get one to sit on here. Here we go. So now I've got this bubble. And I'm going to hold it for the close-up camera here. And you see that region? That is where the white light is shining right on the bubble surface. And you see those little black spots? Those are regions where the bubble film is continuous. It's just not reflecting any light. Let's zoom in a little bit more on that region. And you'll see they're little circles. And the film hasn't popped. Right? It's still a continuous film. And in some places it's reflecting fairly white, but in some places it's just black. Right? So let's zoom out for a second. The bubble is still there. Right? Even further out, the bubble's still got a bubble. But some parts of it are black. And as it goes to where it's going to die and pop, those black regions get a little bigger and bigger. So now let's go all the way in and watch the black regions. While we wait for this. Oh, and there it goes. Right as we were zooming in. Maybe the lens hit it. It popped. So what's happening here? This is a little bit strange. Why does it go black? Well, it's just following the exact laws of physics that we've derived. As the bubble gets really thin, this term goes to zero, right? This gets really small. As it gets really thin, the reason it lost its color, it goes kind of gray, is because when this gets really small, changing this by a factor of 2 or something doesn't matter much, right? You're getting sort of close to the zero of this cosine, right? And you're getting close to a zero because of this term, right? So if you take the thickness all the way to zero, right, give it no thickness, a super thin film compared to the wavelength of light, that's those black patches. And those patches are black because there's still a phase difference. The reflection off the front and the reflection off the back, even if the thickness is very, very small, has a pi/2 phase difference. That's this term. That's why it goes black. But even as it's really thin, the difference you're going to get is not going to vary that much, right? If I decrease t here, that spreads out the spacing of this, and it basically becomes flat and invisible. That's why that really thin area, the parts where you could still see something were kind of white, but then the parts that went really thin, although there were still molecules there, went black because of the pi/2. So don't just watch the bubbles when they're healthy and colorful, watch them when they're on the verge of collapse, and you'll see this interesting effect.